Assalamualaikum. Our group had made an assignment for CHM132, which is the title is the organic chemistry of caffeine. In this slide, we had put about the structure, the function, and the impact in our daily life.
This slide was prepared by our group members that consist of Muhammad Iman Hakim bin Ahmad Usman, Muhammad Hazim bin Muhammad Hazlan, and my name is Muhammad Hazlan Shah bin Abdul Karim. Also Irfan Zul Amar bin Nur Amiru, Muhammad Daniel Haikal bin Adanan, and lastly Muhammad Ajmal Mikail bin Nur Azlan. So firstly, I will begin with the introduction of the presentation. The name of the compound in its scientific name is 1,3,7-trimethylxanthine, which is commonly known as caffeine. In the middle of the slide, we can see the structure of caffeine. It is an organic compound with a complex ring structure. This diagram shows how different atoms like carbon, hydrogen, nitrogen, and oxygen are arranged within the molecule. Now, moving on to the classification of the compound, caffeine contains several functional groups, including amines, amides, and amine, alkene, and methyl groups. The presence of these functional groups give caffeine its unique properties, such as its stimulating effects and solubility in water. Additionally, caffeine is classified as a tertiary amine. This is because the nitrogen atoms in caffeine are bonded to 3 carbon atoms. These chemical features are important because they help explain how caffeine interacts with our bodies and why it's so commonly used as a stimulant in everyday products like coffee, tea, and energy drinks. Next, I will pass to my colleagues to our next slide. That's all from me. Thank you.
And now I'm going to tell you guys about application of caffeine. Caffeine is widely used across various industries, primarily in beverages, where it serves as a stimulant. For example, coffee contains a lot of caffeine. It can increase alertness, reduce fatigue, and enhance focus, potentially leading to higher output and efficiency in tasks related to coffee farming, processing, or preparation. However, excessive caffeine consumption can also lead to negative side effects like insomnia and anxiety, which might hinder productivity if not managed.
Thank you to Hazim Has. After that, caffeine suitability in coffee production is primarily due to its role as natural pesticide and its ability to help the plant spread and compete for resources. It also contributes to the stimulating effects and flavor profile that consumers associate with coffee. Additionally, caffeine is suitable for use in coffee because its chemical properties allow it to dissolve in hot water, making it extractable during brewing. Its stimulating effects caused by blocking adenosine receptors and boosting dopamine complement coffee's role as an energizing beverage. That's all from me, and I will pass to my friend. Thank you.
Thank you, Ajmal. Right now, I will be explain about the reaction about caffeine. This caffeine can be have the N-methylations of caffeine in the liver metabolism, and the type we can see the bio transformation in the human body as mine cotorcomide P450, mainly CYP1A2. This reaction for the caffeine can be paraxanthite plus formaldehyde. After that, this we will have another reaction like dimethyl hexylhide like theobromine or theopolyslide. From example, reaction caffeine C8 H10 and 4O2 will be parazylhide. C7H8 and 4O2 plus formaldehyde CH2O. Finally, for functional, this process reduce caffeine activity and prepare it for execution. That's all for me. I will pass to another slide to my friends.
Assalamualaikum and a very good morning to everyone. Today, I would like to talk about caffeine oxidation by potassium permanganate, also known as KMNO4. This is a type of oxidation reaction and it usually takes place in a laboratory reaction. Let me give you a quick overview of what happens in this reaction. Caffeine, which we usually find in drinks like coffee, tea, can be broken down by a strong oxidizing agent, which is potassium permanganate. This chemical helps break caffeine into smaller pieces, such as carboxylic acids and nitrogen-containing products. The simplified chemical reaction is C8H10 and 4O2 plus KMNO4 produce CO2 plus NH3 plus other oxidized fragments. In simple terms, caffeine reacts with potassium permanganate to produce carbon dioxide, ammonia, and other byproducts. This reaction is especially useful in chemical analysis because it helps scientists study how caffeine breaks down and what compounds are produced. In conclusion, caffeine oxidation is a good example of how chemistry helps us understand even the common things we consume daily like caffeine. That's all from me. Thank you.